Hi, I'm Tomasz Limisiewicz from Charles University, Prague. I'll present our work. You can have your data and balance it too, towards balanced and effective multilingual models. It is joint work with Malkin and Gabriel Stanovsky from the Hebrew University of Jerusalem. As you probably know, multilingual language modeling gained immense popularity in recent years due to its ability to represent multiple languages in just one model. However, there are drawbacks to this approach. Some languages are severely underrepresented in where resources used to train those models. It translates to much lower performance of the representations learned by those models. In this work, we'll ask whether it's possible to improve performance on low resource languages by preserving the good performance on high resource ones. To start with, let's take a closer look on how multilingual language models are trained. Usually, the training is done on all available data, which are unbalanced across languages. We change this paradigm by training the model on balanced data. To do so, we constrain the data to the amount of data available for the least resourceful language. In this approach, the multilingual model is exposed to much lower number of training steps. To cope with that, we substitute the original training loss, so-called hard labels loss, which awards the model only for picking the originally masked word, with soft labels loss, which accounts for the probabilities of all possible candidates for the masked word. The distribution for those candidates will be taken from the teacher models, which are monolingual language models trained on all available data. It's important to note that such teacher-to-student training, also known as knowledge distillation, have already been used before. The main differences in our methods that we only use soft labels for student model. We use multiple teacher, one of each is specialized in specific language. Our method is aimed to scale down the data to correct balanced performance instead of the previous methods, which mostly were aimed to scale down the model, such as distilled paired. We'll compare three methods of training multilingual language models. The first one, the most standard one, is the hard labels trained on all data. The second is hard labels with balanced training data. The third is our distillation with soft labels when we first train teachers on all data and then distill knowledge on balanced data set. We'll conduct experiments in 13 languages. The yellow languages are the high resource ones. We'll also split the training languages into two groups based on the feature whether they share script or whether they have diverse script to see for which set of languages our method is better applicable. We'll evaluate the models threefold. First, of language modeling, original objective, and two downstream tasks, part-to-speech tagging and name entity recognition. In language modeling, we see that for low resource languages, the highest performance is obtained by hard labels balanced model, followed by our approach and the regular way of training multilingual language models. The trend is reversed for high resource languages. However, we see that our model obtains the most steady results. Similar trend is visible for the languages with diverse scripts. But here we see that for low resource languages, our model performs the best. In zero-shot transfer, our method beats the baselines for part-to-speech tagging. It's also the best for name entity recognition, with exceptions of low resource settings when it's slightly worse than naive balancing. We also have achieved good results in a case when training and test set are in the same language. For the last evaluation, we compare sharing of the script. On the example of German, we show that having diverse scripts in the training languages could be beneficial, for instance, for part-of-speech tagging, and is detrimental from name recognition. All in all, we showed a new competitive way of training multilingual language models. However, future work is needed to validate our methods on larger models. Thank you for your attention. I'll be happy to take your questions in person.